Hi dear students, this is the sixth lesson about the chapter Analytic Analysis of Lines. Our topic is trigonometric ratios of angles, acute angles, and the right triangles. Because of the tangent here, tangent is going to be the slope of the line also. That's why we are learning this here. Okay, let me remind you about the trigonometric ratios now. You know, in the triangle, right triangle it should be. In the right triangle, we have three sides like A, B, C. A is also called hypotenuse. Hypotenuse. So, with respect to this information, the sine of alpha, it's going to be C opposite over hypotenuse, which is equal to A. Opposite over hypotenuse. Adjacent of alpha b over a, it's going to be cosine alpha, and tangent alpha opposite over adjacent c over b, and cotangent alpha, it's going to be b over c. These are the first four trigonometric ratios that we are learning. We have two more, but in general we are using these four of them. And since we have the right triangle, in the right triangle we have two angles like different than 90 degree. They are complementary angle also, they are called alpha plus beta s, since it's equal to 90 degree. Sine alpha is equal to cosine beta, it has to be, and this is equal to c over a. Sine alpha, if you remember, c over a, and cosine beta c over a also. So also we are using this one as trigonometric ratios. For converting the trigonometric ratios, cosine alpha, it's going to be equal to sine beta, which is equal to b over a. So, you know, from the trigonometric, converting the trigonometric ratio, since beta and alpha plus beta is equal to 90 degree, then beta becomes 90 minus alpha, or beta is equal to, in trigonometry, pi over 2 minus alpha also we are using. So cosine beta, when we say, is equal to cosine pi over 2 minus alpha also. It's going to be, and this conversion becomes sine alpha. Okay. So if we continue with the known and special angles, you know, 0 degree, 30 degree, 45, 60, and 90 degree, these are special angles for us. And we need to know, somehow we need to memorize sine and cosine of them. So also the tangent we are going to use in the trigonometric ratios. That's why it is important for us. Here there is one conclusion also. It is not shown. Yes, here it's like this. So, you know, for the angle 45 degree, in the right triangle, 45 and 45 it should be, which is isosceles right triangle. If the side is 1 or 2, whatever it is, then this one, it should be equal to root 2. So if you're talking about sine alpha, sine 45 here, it's going to be equal to 1 over root 2. Opposite is 1, and the hypotenuse is root 2. But since the mathematicians, they don't like the root at the denominator, they will rationalize the denominator by root 2, and the answer is going to be root 2 times 1, it is equal to root 2. Root 2 times root 2 is equal to root 4, which is equal to root 4 is equal to 2. So sine 45, it should be equal to root 2 over 2. And here we have cosine, sine and cosine 30. We can calculate by using the sine and cosine 30 of the equilateral triangle. Here this is equilateral triangle, and it divided, we are dividing into two identical right triangle, and the angle here, it should be 30 and 30, so these are 60 and 60, totally this is 60 also. So we have two right triangles and they are identical, and by using the Pythagorean theorem we are finding the third side, which is equal to root 3 here, and I'm not going to calculate how it is by using the Pythagorean theorem, I have already told this one. So this is going to be root 3, and opposite sine 30, which is opposite over hypotenuse, it's equal to 1 over 2, it's going to be, and cosine 30, it's equal to root 3 over 2. Also here it is written cosine 30 is root 3 over 2. And it is same for the sine 60. Sine 60 is equal to root 3 over 2, and cosine 60 is equal to 1 over 2. It's going to be also they are written here in this table. But I want to tell about this table, maybe interesting for you. This is here, let's say it's equal to 0 over 2, and it is equal to 1 over 2. This is root 2 over 2, root 3 over 2, and the last one is root 4 over 2, which is equal to 2 over 2. That's also equal to 1. So what is the condition here? This is all the numerators here. They are continuing with the order 0, 1, 2, 3, 4, the first 4 natural numbers. Root 0, root 1, root 2, root 3, root 4, all over 2. And if you don't mix the order of the numbers here, like, the order of the angles, 0, 30, 45, 60, and 90, it's easy to memorize this order, I think. And cosine, what should be the cosine? Cosine of the angles are always opposite. Let's say 1 and 1 here, as you see. Then root 3 comes here, then root 2 and root 2, both of them the same. Then root 1 is here, then 0 is here. So you are writing reversely this order for the cosine. So it's easy to memorize, I think. And tangent also, you need to know this one. For the tangent, we know that tangent is also sine over cosine. So tangent, if you are looking for tangent 30, which is equal to sine 30 over cosine 30, and without looking at the table, if sine 30 is equal to 1 over 2, cosine 30 should be root 3 over 2. Then if you simplify, the answer is going to be equal to 1 over root 3. But as I mentioned, we don't like the fraction, radicals in the fraction. So we should rationalize the denominator, and we are going to multiply by root 3. Then the result is going to be root 3 over 3. Also, it's written sine tangent 30. You can find easily if you don't remember the value of it. And sine 45 over cosine 45, root 2 over 2 over root 2 over 2, a over a, which is equal to 1. So it's easy to find the tangent values also. Tangent y is important for us. I told you that's the slope of the line. It shows the slope of the line to us. Here, trigonometric conversions, you remember from the trigonometry. I'm not going to continue to this part, but you need to remember cosine 180 minus alpha is equal to minus cosine alpha. Sine 180 minus alpha, it's going to be sine alpha. Tangent 180 minus alpha is equal to minus tangent alpha. which means that if alpha is equal to, let's say, 30 degree, if this 30 is spatial angle for us also, 180 minus 30, it's going to be spatial for us, which is 150. Because, as it mentioned here, cosine 180 minus 30, which is equal to minus cosine 30. You know cosine 30 from the table. You will remember from the table. And this is equal to cosine 150. So cosine 150 is equal to minus cosine 30, which is equal to, here, I need to go a bit down, cosine 30, cosine 30, it's going to be equal to root 3 over 2 here in the table. So cosine 150 also minus root 3 over 2, it's going to be, this is because of the conversion between the trigonometric units. Okay, let's continue with some exercises. Find the tangent values of the angles 120. So we are looking for tangent and tangent 120 and tangent 150. So we remember that 120 is equal to 180 minus 60. It's going to be. You need to be careful here. You should use 180. Let's say 150 minus 30 also, it is 120, but we are going to use 150, 180 or 90 degree for this kind of questions, because these are the, on the unit circle, these are the critical points, which means the coordinate of the intercepts of the unit circle. That's why we are using 180, 90, and 270, 360 degrees. That's why they are important for us. Tangent 120, so it's going to be 180. It's going to be equal to tangent 180 minus 60, which is equal to minus tangent 60. So tangent 120 is equal to minus tangent 60, and tangent 60, it's going to be equal to root 3 over 1, which is equal to root 3. So tangent 120 is equal to minus tangent 60, since it's equal to root 3, I thought, minus root 3 it has to be. What about tangent 150? Tangent 150, it's equal to 180 minus 30, which is equal to minus tangent 30. So tangent 150 is equal to tangent 30 is equal to 1 over root 3, or minus root, not minus, root 3 over 3. We have the minus sign here. Root 3 over 3, which is equal to minus root 3 over 3. It should be tangent 150 is equal to minus root 3 over 3. It has to be. Okay, this is the end of our lesson.